June 14, 2026, 11:47 p.m. A Storm Shadow cruise missile traveling at 1,000 kilometers per hour crosses a border that Russian military doctrine said couldn't be crossed. 1,500 kilometers from Ukrainian soil, deep inside Russian territory. The Orenburg Gas Processing Megacomplex, one of the largest natural gas compression and export facilities on the planet, sits quiet under a moonless sky. 12 billion cubic meters of annual throughput, 3 S-400 battery positions around the perimeter, an interceptor squadron on 5-minute alert at the adjacent airfield. Russian planners had spent 2 years assessing this site's vulnerability and reached the same conclusion every time. Untouchable, beyond reach, safe. They were wrong about all of it. I'm your host at War Vector, where we analyze the battles that change wars. What happened over Orenburg on the night of June 14, 2026, didn't just change a battle, it changed the entire strategic calculus of this war. Because what Ukraine executed that night wasn't a long-range strike, it was a deception operation, so precisely engineered that Russian air defense, one of the most expensive, most layered, most sensor-dense systems ever fielded, was looking the wrong direction when the missiles arrived. The compression station burned for 72 hours, and what it left behind will be studied in military academies for the next 50 years. Stay with us, because the story of how this happened begins not over Orenburg, but over Belarus. And it begins 4 hours earlier than anyone in Moscow expected. To understand what Ukraine accomplished on June 14th, you need to understand what Russia believed was protecting the Orenburg facility. The Orenburg Gas Processing Megacomplex is infrastructure of strategic consequence. Located in the southern Ural region, approximately 1,500 kilometers northeast of the Ukrainian border, it processes natural gas from multiple Siberian and Central Asian pipeline corridors. Its primary compression station drives export volumes through pipelines feeding Turkey, Central Asian republics, and markets that generate hard currency for the Russian state. Destroying it doesn't just hurt Russia operationally, it attacks the revenue stream that funds the war. Russian military planners had evaluated this site against every credible Ukrainian strike capability as of late 2025. Storm Shadow missiles, supplied by the United Kingdom, carry a range of approximately 560 kilometers in standard operational configuration. Even accounting for trajectory optimization and fuel efficiency, Ukrainian platforms launching from western Ukrainian airbases could not credibly reach 1,500 kilometers. The math didn't work. Russian analysts said so in internal assessments that Ukrainian intelligence later confirmed had been circulated at the deputy minister level. The site was classified as depth secure. The S-400 batteries around the facility were configured for intercepting ballistic threats and aircraft, not for high-alert cruise missile defense on a vector nobody expected to be active. What Russia failed to account for was the F-16. Ukraine received its first batch of F-16 Fighting Falcons in mid-2024, drawn from Dutch and Danish Air Force inventories. By late 2025, Ukrainian pilots, many trained under accelerated NATO programs, had accumulated meaningful operational hours. But the F-16's value to Ukraine was never purely kinetic. It was doctrinal. The F-16 gave Ukrainian planners a supersonic, radar signature variable platform, capable of executing complex deception operations. A platform that Russian radar operators could track. A platform that looked threatening enough on a scope to demand interceptor response. A platform that could be somewhere other than where the real strike was coming from. Which weapon proved deadlier in modern warfare? HIMARS precision rockets, conventional artillery, or drone systems? Drop your answer. A for HIMARS, B for artillery, C for drones, in the comments. We'll come back to this. Ukrainian General Staff planning documents, later partially described in open-source reporting, indicate that the Orenburg operation had been in development for approximately 4 months before execution. The concept was deceptively simple. Russian air defense doctrine, as Ukrainian analysts had studied it, contained a structural assumption that interceptor alert queues and long-range missile tracking queues drew from the same command and control bandwidth. In practical terms, if Russian air defense controllers were managing an active fighter threat on one vector, their cognitive and computational attention was split. The Integrated Air Defense System, IADS, wasn't infinitely scalable. Push it hard on one axis, and coverage degraded on another. Ukrainian planners had spent months looking for the precise conditions under which that degradation would be most severe. They found it in a combination of timing, weather, and geography that existed on the night of June 14, 2026. I spent weeks going through every open-source fragment of what emerged about this operations planning phase. Ukrainian OSINT reporting, satellite imagery analysis, European defense commentary, and one detail kept nagging at me. The Belarusian feint was announced, in effect, by Ukrainian flight activity 3 nights before the actual strike. Small, deliberate sorties that moved toward the Belarusian corridor and turned back. Not enough to trigger a full response. Enough to establish a pattern. Enough to make Russian radar operators expect that the next time Ukrainian jets moved north, it was probably another probe, not the real thing. Ukraine didn't just execute a deception on the night of the strike. Ukraine spent 3 days training Russian radar operators to ignore the feint. At 7:51 p.m. on June 14th, 4 Ukrainian F-16s lifted off from a western airbase. Flight path, northeast, toward Belarus. Altitude, medium, easily visible to Russian surveillance radar. Their transponders were configured to maximize radar cross-section. These jets wanted to be seen. They pushed toward the Belarusian border corridor at high speed, triggering the exact response Ukrainian planners had anticipated. Russian radar networks lit up. Intercept requests went up the command chain. 2 Su-35S fighters from the 14th Air Army scrambled from their alert station. Ground-based radar slewed north. The attention of the Russian IADS, for a critical window, bent toward Belarus. Simultaneously, and this is the part that exposes just how much Ukrainian intelligence had penetrated Russian operational patterns. Storm Shadow missiles were already in the air. The launch packages had taken off 32 minutes earlier, at 7:19 p.m., from a different airbase entirely. 4 Ukrainian Su-24M Fencer strike aircraft, modified for Storm Shadow carriage, flying low, using terrain masking over the Carpathian foothills to suppress their radar signature until they reached their launch release points. Each aircraft carried 2 Storm Shadow missiles, 8 missiles total in the first wave. A second wave of 4 more missiles followed at a staggered 8-minute interval, 12 Storm Shadows in total, routed not north toward Belarus, but south and east, threading a corridor that hugged the Kazakhstan-adjacent airspace boundary where Russian radar coverage had known geometric gaps. Satellite imagery analysis confirmed that the southern routing was deliberate. Ukrainian planners had identified a gap in Russian over-the-horizon radar coverage, created by the curvature of terrain and the placement of forward radar nodes. The Storm Shadow, flying at very low altitude, terrain-following mode, as low as 30 meters above ground in stretches, could exploit that gap for a significant portion of its flight profile. It would only appear on Russian air defense radar approximately 220 to 240 kilometers from the target. At that point, the missile was traveling at roughly 1,000 kilometers per hour. Detection to impact, approximately 13 to 15 minutes. Stay with me, because what happens in the next segment, when those missiles finally appear on Russian radar and the clock starts running, is the sequence that exposes the complete failure of Russian air defense doctrine, and it ends in fire. The S-400 system is formidable. Let's be precise about what it can do. The S-400 Triumph uses a combination of radar systems, the 91 N6E acquisition radar and the 92 N6E engagement radar, to track and engage targets at ranges up to 400 kilometers for certain threat categories. Against cruise missiles flying low and fast, its effective engagement range is considerably shorter. Against a storm shadow flying at terrain-following altitude in electronic emissions control mode, the practical detection to engagement window closes dramatically. The 3 S-400 batteries around Orenburg were positioned for ballistic missile defense and aircraft interception. Their radar elevation profiles were optimized for high-angle threats. The storm shadow, coming in low from the southwest on a vector nobody had assessed as credible, was not the geometry these systems were calibrated for. At 11:31 p.m., the first storm shadow package appeared on Russian radar. The duty controller at the Orenburg Air Defense Command Post had approximately 14 minutes before impact. He had 4 immediate problems. First, the radar track was ambiguous. Low-flying, radar-absorbing profile, appearing suddenly from a direction assessed as non-threat. Initial classification was uncertain. Could be civilian aircraft, could be a sensor artifact. 17 seconds lost to verification. Second, the interceptor alert at the Orenburg airfield had already been partially depleted. The Su-35s, scrambled earlier in the night for the Belarusian feint, were refueling. The jets available for immediate launch were 2 Su-30SMs, capable aircraft, but not on the highest alert tier. Third, the command authorization chain for engaging targets at this range, on this vector, required confirmation from a senior controller. That controller was not immediately on the net. Fourth, and this is the structural failure Ukrainian planners had built their entire operation around, the alert queue for the interceptors and the engagement queue for the S-400 batteries were being managed through the same command node. The node was already stressed by the northern threat management. Adding a simultaneous southern cruise missile track created a processing delay that the Russian system was not designed to handle at speed. How many Storm Shadow missiles did Ukraine fire in the Orenburg strike package? A. 6. B. 12. C. 8. Lock in your answer. We'll give you the exact number and the breakdown at the end. 11 minutes and 40 seconds after initial radar detection, the first Storm Shadow reached the outer fence of the Orenburg Gas Processing Megacomplex. By that point, Russian controllers had managed to vector the 2 Su-30SMs toward an intercept trajectory. They were too far. The geometry was impossible. The missiles were already in terminal phase, broach warhead configuration, designed to defeat hardened structures through a 2-stage penetration sequence. The first charge opens the structure. The second detonates inside. Against reinforced industrial compression equipment, the effect is catastrophic. 3 Storm Shadows hit the primary compression station in a sequence spanning 41 seconds. The first hit the main compressor hall on its northern face, penetrating the reinforced concrete roof. The second hit the high-pressure manifold junction, the single most critical node in the compression pathway, destroying it instantly. The third hit the adjacent gas treatment unit, which contained pressurized methane in processing volumes. The resulting secondary explosion showed up on European satellite imagery the following morning as a thermal bloom approximately 800 meters in diameter. Here's what's most surprising about the Orenburg strike, and it's not the missiles themselves. It's what the secondary explosions revealed about Russian industrial security doctrine. The gas treatment unit that took the third impact had been assessed in Russian infrastructure security reviews as a low-priority hardening target because it was considered too far from the facility perimeter to be a credible strike aim point. Ukrainian targeting had identified it not because of classified intelligence, but because of publicly available industrial engineering documents that described the Orenburg facility's processing architecture. The most damaging hit came from a target that Russia had declined to harden because they couldn't imagine anyone hitting it at all. When you assume a target is unreachable, you stop protecting it like it's reachable. What this operation reveals is the danger of distance-based security thinking. Russia had built its deep rear protection doctrine on one assumption: that range was an absolute barrier. Ukraine spent 4 months proving it isn't. In the modern precision strike era, distance is a planning problem. It is not a defense. 4 additional Storm Shadows from the second wave, hit storage infrastructure and the eastern pipeline junction over the following 11 minutes. By 12:02 a.m. on June 15th, the primary compression station was fully ablaze. Fire suppression systems had been destroyed in the initial impacts. Industrial foam suppression required manual activation by personnel who had evacuated after the first explosion. The fires burned without suppression for over 4 hours before emergency response teams could approach. Intercepted communications, fragments of which emerged through Ukrainian intelligence channels over the following days, indicated significant confusion in the Russian command structure in the immediate aftermath. One exchange, described by Ukrainian sources as authentic, showed a regional defense coordinator asking whether the attack had come from a drone swarm launched from inside Russia. The idea that storm shadows had traveled 1,500 kilometers and threaded his air defense network had not, apparently, been his first hypothesis. That detail tells you everything about how Russian planners had calibrated their threat expectations. Put yourself in the position of that Russian air defense commander for a moment. You've had 3 consecutive quiet nights where Ukrainian jets probed north and turned back. You've been managing low-level drone activity for weeks, and then, at 11:31 p.m., 8 seconds after you stop thinking about Belarus, 12 cruise missiles appear on your radar from the southwest. You have 14 minutes. Your best interceptors are refueling. Your command node is overloaded. Your S-400s are pointed the wrong way. What do you do? The answer, on June 14, 2026, was not enough. The Russian government's response to the Orenburg strike was instructive in its own way. For the first 48 hours, official communications attributed the compression station failure to a technical malfunction resulting from equipment degradation. This was not an implausible cover story in the short term. Orenburg's infrastructure had been flagged in industry reporting for maintenance backlogs. But satellite imagery from commercial providers, publicly released within 36 hours of the strike, showed thermal signatures and structural damage patterns consistent with explosive penetration, not industrial accident. The burn pattern from the secondary gas ignition was inconsistent with any credible mechanical failure scenario. By hour 52, Russian state media shifted to acknowledging a Ukrainian terrorist attack while simultaneously insisting that air defenses had performed effectively and that damage was contained. The damage was not contained. Ukrainian General Staff reporting, cross-referenced with satellite analysis from multiple open-source intelligence platforms, assessed that the primary compression station would require a minimum of 8 to 14 months to return to operational capacity, assuming replacement components could be sourced, which, under current sanctions regimes, was a significant challenge. The eastern pipeline junction damage was assessed as requiring 3 to 5 months of repair. Combined throughput impact, an estimated 40 to 60% reduction in Orenburg's gas processing capacity for the remainder of 2026. Ukrainian OSINT analysts estimated the revenue impact in the range of $800 million to $1.2 billion over the disruption period, based on publicly available pipeline export pricing data. Here's the take that will generate some disagreement. Russia's failure at Orenburg wasn't primarily a technical air defense failure. It was an intelligence failure. Russian planners knew the Storm Shadow's nominal range. They knew Ukrainian aircraft availability. They had access to the same engineering math that said 1,500 kilometers was beyond reach. The failure was that Russian analysts trusted their own assessment and stopped asking whether Ukrainian planners might find a way around it. Ukraine didn't break the physics. Ukraine broke the assumption. And in warfare, unexamined assumptions are the most dangerous vulnerabilities of all. Real tactics, real consequences. War Vector. Subscribe to War Vector if you want to understand how modern warfare actually works. Not the propaganda, not the headlines. The actual decisions, the actual systems, the actual tactical logic behind what changes wars. The operational deception architecture that Ukraine built for the Orenburg strike had 3 distinct layers, and understanding all 3 is essential to grasping why it worked. Layer 1. the long preparation feint. Ukrainian F-16s flew probe sorties toward Belarus on the 3 nights preceding the strike, not aggressive enough to trigger full Russian response, consistent enough to establish a behavioral pattern in Russian radar operator expectations. By the 4th night, when the full feint package launched, Russian radar operators had been conditioned, in the Pavlovian sense, to expect that northbound Ukrainian jets turned around. That conditioning bought critical seconds of hesitation on the night of the actual strike. Layer 2. The simultaneous execution window. The F-16 feint package and the Storm Shadow launch sequence were not separated by hours. They were separated by 32 minutes, precisely calculated to ensure that the missiles were already deep into their cruise profile when the feint triggered the Russian interceptor response. Ukrainian planners needed Russian IADS attention bent north at the moment the missiles appeared on radar from the southwest. The 32-minute gap was not arbitrary. It was the calculated flight time required to place the missiles at the radar appearance point simultaneously with peak Russian command and control stress from the northern threat. Layer 3. The routing corridor. This is the piece that required the most detailed intelligence work. The southern corridor through Kazakhstan-adjacent airspace was not simply chosen because it was long. It was chosen because Ukrainian analysts had identified a specific geometry in Russian radar coverage that created a shadow zone at low altitude along that approach vector. Exploiting it required precise knowledge of Russian radar node positions, their coverage parameters, and the terrain masking available along the corridor. Ukrainian intelligence had been building that picture for months, drawing on satellite reconnaissance, signals intelligence, and open-source data on Russian air defense installations. 3 obstacles threatened to unravel this plan before a single missile launched, and this is where the story gets underreported. First, weather. A high-pressure ridge over the southern corridor in the 48 hours before the strike had created atmospheric ducting conditions that, under some scenarios, could have enhanced Russian radar performance at low altitudes, potentially collapsing the shadow zone the southern routing depended on. Ukrainian meteorological analysts monitored the ridge movement hourly. The ducting conditions dissipated on June 13th, 12 hours before the launch window. The operation had a 24-hour delay contingency that was never needed, but it came close. Second, one of the 4 Su-24M launch aircraft developed a hydraulic fault during pre-flight checks on the evening of June 14th. The aircraft was pulled from the mission. Its 2 Storm Shadows were redistributed, one to another aircraft brought forward from a reserve slot, one removed from the strike package. This is why the final count was 12 missiles, not the originally planned 14. The redistribution took 47 minutes and delayed the overall launch sequence by 19 minutes, compressing the timing margins that had been built into the coordination plan. Third, Ukrainian signals intelligence detected an anomaly in Russian radar activity north of Orenburg at approximately 5 p.m. on June 14th, several hours before the planned launch. A Russian airborne early warning aircraft, an A-50 mainstay, was operating in an area that could have complicated the southern corridor approach. The A-50, if it stayed on station, would have provided radar coverage that the ground-based systems lacked. Ukrainian planners assessed that the A-50 was conducting a scheduled patrol and would rotate off-station before the strike window. The assessment proved correct. The aircraft landed at 9:40 p.m., but for 3 hours that afternoon, the operation balanced on that judgment call. If you believe tactics win wars, and you believe that the most important victories in this conflict are being won by planners and analysts, as much as by pilots and drone operators, type war vector in the comments. By 6 a.m. on June 15th, satellite imagery showed the Orenburg facility wreathed in smoke that could be tracked at altitude. Emergency response teams had managed to suppress the most acute fire hazard by deploying foam from safe distances, but the compression hull remained too structurally unstable to enter. Russian energy officials who arrived on scene that morning found a primary compression station that would need to be essentially rebuilt. The manifold junction infrastructure, the specific node the second Storm Shadow had targeted, required components with global lead times of 9 to 14 months under normal procurement conditions. Under sanctions, Russia's options were domestic manufacture, which was capacity constrained, or gray market procurement through third-party intermediaries, which was slower and more expensive. There's a line in the open-source damage assessment from a European infrastructure analysis group that reads almost like fiction. They estimated that the repair timeline could be shortened by approximately 4 months if Russia could access European turbomachinery components, the same components that European export controls had restricted since 2022. The machinery that could fix the plant Russia had declared untouchable was the machinery Russia had been cut off from. The sanctions and the strike were, in retrospect, a compound system. Ukraine hit the facility. The West made the recovery as hard as possible. Russian air defense adjustments in the weeks following Orenburg were documented through open-source analysis of radar activity patterns and interceptor deployment movements. 3 observable changes emerged. First, additional radar nodes were repositioned to improve low-altitude coverage on southern approach vectors, but this created coverage gaps on other axes, because Russia doesn't have unlimited radar assets to spread everywhere simultaneously. Second, S-400 battery operational procedures were apparently modified to allow faster autonomous engagement authorization at the battery level, reducing the command node dependency that had contributed to the response delay at Orenburg. Third, Russia repositioned one of its A-50 mainstay aircraft to provide persistent airborne radar coverage of the Orenburg region, but this pulled an asset away from other priority coverage zones. What NATO analysts noted, reviewing these adjustments, was that Russia was patching individual holes rather than addressing the structural doctrine problem. Layered air defense that cannot simultaneously manage multiple simultaneous threat vectors is not made robust by adding more coverage in the place you just got hit. It's made robust by redesigning the command and control architecture so that it scales under simultaneous load. Russia's IADS wasn't patched, it was bandaged. What would NATO have done differently to defend a facility at this depth? The structural answer probably involves persistent drone-based radar pickets at 200 to 300 kilometer radius around critical infrastructure. Systems that don't depend on ground-based geometry and can maintain low-altitude coverage in all directions simultaneously. NATO doctrine for deep asset protection has moved toward distributed radar sensing precisely because centralized ground-based nodes create the kind of geometric gaps that Orenburg exposed. Russia knows this. The technical and economic barrier to implementing it across all of Russia's now vulnerable deep rear infrastructure is, by most assessments, beyond Russia's current capacity. Comment your analysis of what NATO doctrine would have required here. By mid-June, the strategic implications of Orenburg had begun to reshape Ukrainian targeting doctrine in ways that were discussed, if not fully disclosed, in Ukrainian defense commentary. The operation had proved that the 1,500-kilometer barrier was penetrable under the right deception conditions. It had proved that F-16s were not just air superiority platforms, they were deception enablers, capable of bending Russian IADS attention to create windows for other strike packages. And it had proved that Russian infrastructure confidence was misplaced at any depth. Ukrainian sources in the weeks after the strike described, without confirming specific targets, that planning teams were reviewing a list of deep rear facilities that had previously been assessed as beyond reach. The Orenburg success hadn't just destroyed a compression station, it had opened a planning folder that Russian analysts had assumed would stay closed. The detail that stuck with me most, going through the open-source material on this operation, is how mundane the decisive factor was. Not the missiles, not the F-16s, not the routing corridor. The decisive factor was 3 reconnaissance sorties on 3 quiet nights before the strike, training Russian radar operators to expect a feint to turn back. That's it. 3 nights of deliberate behavioral conditioning. The most expensive air defense system Russia could field was ultimately defeated, in a meaningful sense, by psychology. Ukrainian planners understood that the human operator inside the system was the exploitable vulnerability. The radar hardware was formidable. The human being watching the screen at 11:31 p.m., who had seen this pattern 3 times before and categorized it accordingly, that was the gap. Ever dealt with a situation where the most complex problem had the simplest solution? Comment below. We read every single one. The fires at Orenburg were fully extinguished by the morning of June 17th, 3 days after the strike. By then, European satellite imagery had been reviewed by at least 6 independent analytical organizations, all reaching broadly similar damage assessments. The Russian government's official position had completed its evolution from technical malfunction to Ukrainian attack with minimal impact, a formulation that the satellite imagery made factually difficult to sustain, but which served the domestic information environment. Putin's energy officials, in internal meetings described by Kremlin-adjacent sources to Russian opposition media, were significantly less optimistic. Reconstruction costs were estimated at between $400 million and $700 million. Timeline to full operational restoration. Optimistic scenario, 12 months. Realistic scenario, 18 to 24 months. For Ukraine, the Orenburg operation was doctrinal confirmation. The theory that deception-enabled long-range strikes could penetrate Russian air defense at any depth had been tested under real operational conditions against a real high-value target defended by real S-400 systems. The theory had held. Ukrainian planning teams had not just executed a strike, they had validated a methodology, real tactics, real consequences, war vector, and Russia's assumption that depth equals safety had been written in fire. Now to the tactical lessons. Because this is where Orenburg stops being a single event and becomes a template. Lesson 1. Deception is a force multiplier that doesn't appear in equipment counts. Ukraine operated fewer aircraft than Russia maintained on alert. Ukraine fired 12 missiles against a facility defended by 3 S-400 batteries. On paper, those numbers favor the defender. But Ukraine invested in the one asset that doesn't show up on an order of battle: preparation. 4 months of intelligence collection, 3 nights of behavioral conditioning, 19 minutes of contingency response to a hydraulic fault. Preparation defeated Russia's numerical advantage more completely than any counter-battery fire could have. Lesson 2. Integrated air defense systems are only as robust as their command and control architecture under simultaneous load. The S-400 hardware at Orenburg performed within its design parameters. The system that failed was not the missile battery. It was the human and procedural chain that coordinated interceptors and surface-to-air missiles through the same command node. When that node was stressed by the northern feint, response quality degraded on the southern vector. Redundancy in hardware without redundancy in command processing is not true redundancy. Lesson 3. Infrastructure depth is not infrastructure security. Orenburg was 1,500 kilometers from the front. Russian planners had assessed that distance as a security parameter and reduced hardening and alert posture accordingly. Ukraine proved that in the precision strike era, the relevant question is not how far a target is from the launcher. It is whether the corridor to that target can be made viable under deception conditions. For Russia, this lesson implies that every piece of critical infrastructure, at any depth, now requires active rather than passive defense. The resource cost of implementing that at scale is enormous. Now, the quiz answer from earlier in our analysis. How many Storm Shadow missiles did Ukraine fire in the Orenburg strike package? The correct answer is B, 12. The original planning called for 14 missiles across 4 Su-24M aircraft, 2 per aircraft. A hydraulic fault grounded 1 aircraft before launch, and its 2 missiles were redistributed. 1 joined another aircraft's payload, and 1 was removed from the package to maintain weight and balance parameters. The resulting strike package was 12 missiles in 2 waves, 8 in the first wave at 7:19 p.m., 4 in the second wave 8 minutes later. 3 missiles hit the primary compression station. 4 hit the eastern pipeline junction and storage infrastructure. 5 were intercepted or missed their aim points. A success rate of approximately 58% against defended targets at extreme range, which Ukrainian analysts assessed as within acceptable parameters for a first-generation deception-enabled strike of this complexity. 3 questions this operation leaves open. Was the decision to execute the strike with 12 missiles rather than the planned 14 the right call, given that 2 additional missiles might have hit the secondary treatment units that survived? Could Russian air defense have prevented the strike if a single A-50 mainstay had remained on station over the southern corridor through the strike window? And what would you have done differently? As a Ukrainian planner with 4 months of preparation, a partial aircraft fault 90 minutes before launch, and a 72-hour weather window closing behind you, will Russia find a way to defend its deep rear infrastructure before Ukraine executes the next strike in this series? Comment yes or no, because based on everything we've just analyzed, there's a genuinely strong case on both sides, and we want to hear your read on it. Subscribe to War Vector, because we break down the battles that textbooks will study for decades. Not the simplified version, the full operational picture, the deception layers, the contingency calls, the doctrine failures, the human decisions inside the machine. The Orenburg facility is quiet now. The fires are out. Workers in protective gear move through the ruins of the compression hall, cataloging damage that will take years and billions to repair. The S-400 radars that were supposed to make this impossible are still scanning the same skies. But somewhere in a Ukrainian planning room, another map is on the table. Another facility that was supposed to be safe. Another corridor being measured. Another deception layer being built. Another night being chosen. Russia built its doctrine on distance. Ukraine just proved distance is a solvable problem. The wreckage at Orenburg is a reminder that modern warfare punishes certainty without mercy. Stay vigilant.